Hi guys! Today we're going to practice using calculations for finding speed and finding acceleration. Okay, so the equation for speed is speed equals distance divided by time. If we manipulate this equation, we can get a similar equation to solve for distance. Distance is equal to speed times time, and time is equal to distance divided by speed. Now, for some of you, it might be easier to remember this way. If you draw a triangle and cut it in half, and then cut the bottom half in half, write distance at the top and speed and time at the bottom. If you're given a distance, you simply multiply speed times time to find the answer. Or if you're supposed to find a distance, you simply multiply speed times time to find distance. If you're given a distance and also a time, you simply divide that distance by the time to find the speed. If you're given a distance and a speed, you simply divide distance by speed to find the time. Now, let's do a few example problems. This one says, what would be the average speed for a trip of 105 kilometers that takes 3.5 hours? Now, I know that my distance is 105 kilometers. And I know that my time is 3.5 hours. What I don't know is my speed. But I do know that my speed is equal to distance divided by time. "105 kilometers divided by 3.5 hours gives us 30 kilometers per hour. Let's move on to the next example. Our next example says, how far will you travel in 4 hours if your average speed is 62 kilometers per hour? We have a time, and we have a speed, and what we don't have is a distance. But I know that if I'm looking for distance, I can find it by multiplying speed times time. "62 kilometers per hour times 4 hours gives us 248 kilometers. Which I will round up to 250. Let's move on to the last example. On Google, I learned that a salamander can run 1.3 meters per second. If Sally, our pet salamander, runs away from John and Carla for 5 minutes, how far will she get? Well, we have a speed that's 1.3 meters per second. We have a time that's 5 minutes, and we don't know our distance. Now, because Sally can run 1.3 meters every single second, we can't simply multiply 1.3 times 5 to get our answer. That will only tell us how far Sally would be able to run in 5 seconds. Now, what we need to do is find out how many seconds there are in 5 minutes. You remember that in every minute there's 60 seconds. So we can simply go 5 times 60 seconds in every minute. Minutes cancels. And 5 times 60 is 300. Yes, it is. 300 seconds. And we can put that into our problem. Distance is equal to speed times time. 1.3 meters per second times 300 seconds tells us that Sally would be able to run 390 meters, which also, according to Google, is about 430 yards. Which is just a little more than 4 football fields. Go, Sally. All right. Now let's move on to acceleration. To find acceleration, you simply take your change in velocity over the amount of time that has passed. The change in velocity, delta V, is equal to whatever velocity you ended at, your final velocity, minus whatever velocity you started with, your initial velocity. So another way to write this equation is like this. Acceleration equals Vf minus Vi over t. Or, if you're solving the equation for time, the time is equal to Vf minus Vi divided by A for acceleration. Let's do a few sample problems. A roller coaster is moving at 25 meters per second at the bottom of a hill. 3 seconds later, it reaches the top of the hill going at 10 meters per second. What is the acceleration of the roller coaster? Well, we know that its initial velocity is where it is at the beginning of the problem, bottom of the hill. So initial velocity is 25 meters per second at the bottom of the hill, and its final velocity at the top of the hill is this, 10 meters per second. It took us 3 seconds to get there. Using this equation, our acceleration is equal to Vf, 10 meters per second, minus Vi, 25 meters per second, divided by t, 3 seconds. 10 minus 25 is a negative 15. Negative 15 divided by 3 tells us that our acceleration is equal to negative 5 meters per second squared. The roller coaster was slowing down as it climbed the hill. Let's go on to the next problem. 2 more left. If a train is going 60 meters per second and hits the brakes, it takes the train 1 minute and 25 seconds to stop. What is the train's acceleration? Now, you've all heard that trains can't slow down very quickly, which is why it's very important to be careful around railroad tracks. So let's look at this problem and break it down a bit. The initial velocity of the train before it hits the brakes is 60 meters per second. It comes to a complete stop, so that means its final velocity is 0 meters per second. This says that it takes a time of 1 minute and 25 seconds. This isn't very useful to us if we leave it as a mixed number. 1 minute is 60 seconds, and 60 plus 25 is 85 seconds total. Now all we need to do is find our acceleration. So, acceleration is equal to VF, which is 0 meters per second, minus VI, the velocity we started with, 60 meters per second, divided by time, 85 seconds. 0 minus 60 is negative 60. Negative 60 divided by 85 seconds gives us negative 0.71 meters per second squared. So trains slow down very slowly. Last question. There is a vehicle with an acceleration of 6.89 meters per second squared. Suppose it accelerates from rest to 96.5 kilometers per hour. How long would it take this vehicle to reach that speed? This will be the most complicated problem we do because we have to convert kilometers per hour into meters per second to make it compatible with our acceleration, which is in meters per second squared. Let's get started. Our acceleration is equal to a positive 6.89 meters per second squared, meaning this car is speeding up. Our initial velocity is rest, which means it's going at 0 meters per second. Now here's the tricky one. Our final velocity is 96.5 kilometers per hour. We want hours to cancel, so we can simply multiply this by that fraction of 1 hour for every 3,600 seconds for hours to cancel. And then we can multiply it by 1,000 meters for every kilometer. In this way, we can get our kilometers to cancel. That'll leave us with meters per second. So, 96.5 divided by 3,600 multiplied by 1,000, we get 26.8 meters per second as our final velocity. Now we have everything we need to find the time. Now again, to find time, we'll use this other equation. Time equals VF minus VI divided by A for acceleration. So 26.8 minus 0 is still going to give us 26.8 divided by our acceleration, which is 6.89 meters per second squared. 26.8 divided by 6.89 meters squared gives us 3.89 seconds. And that's a ridiculously fast car. I feel like that would be fun to sit in while it accelerated. Anyway, hope that made sense. See you guys in class.